Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 4-6, completing the square. Let's begin. First thing first, like always, we're going to start talking about the vocabulary first with a little bit of review. So let's draw a line from each expression to its square root. Well, if I were to take the square root of the very first problem, you're essentially going to be taking the square root of that 25 as well as the square root of the x. And the square root of 25 is going to be a plus or minus 5, and the square root of x squared ends up being that plus or minus, in this case, 5x. We have the x squared plus 4x plus 4. Well, that's the exact same thing as the x plus 2 squared. So if I were to take the square root of that, you would get x plus 2 by itself. Part number 3, we have the 36x squared minus 36x plus 9. Well, we would take the square root of the first and the last term of the a portion with the x squared and that c portion, and you'll end up with a 6x and a 3. The very last step that you have to make sure that you do is pay attention to this sign. Since it's a negative sign on the inside, we're going to take a negative on the inside of the parentheses as well. So we're going to square that, which means if we take the square root, it's going to go back to the 6x minus 3, and obviously the very last one is going to be that 2x minus 5y. Doing the exact same method we did for the previous question. Square root of both will give you that 2x and the 5y, and more importantly, the negative on the inside brings down that negative. Great work. Today we're going to be talking about trinomials. Alright, perfect squares as well, but a trinomial is an expression consisting of 3 terms. Alright, 3 different terms. You can use perfect square trinomials to help solve quadratic equations. And more importantly, we can use this to help solve all quadratic equations. So a 4x squared minus 5x plus 5 is going to be considered a trinomial because it has 1 term, 2 terms, 3 terms. Ax squared is a term, the bx is a term, and that c value is a term. Alright? So in order for something to be trinomial, you would have to have 3 terms because that tri portion, like a tricycle, has 3 wheels. Write the number of terms in each expression. In this case, I have 1, 2, so it's a binomial or 2 terms. We have 1, 2, 3, making this a trinomial. We have 1 right here, making it a monomial. And we have 3 right here, 1, 2, 3, making it a trinomial once more. Put a t next to the expression that is a trinomial. Put an n next to the expression that is not. Well, this is a monomial. There's only 1, so it's an n. This has 3 terms, even though the exponent is different from what we've been seeing. It is still 3 terms. We have 1, 2, 3 terms, therefore it is going to be a trinomial. This one also is a trinomial because, again, 3 different terms. And the very last one is a binomial because there's only 2 terms. So it's not going to be considered trinomial. Cross out the expression that is not a perfect square trinomial. In order for you to be able to figure out if it's a perfect square trinomial or not, you take the square root of both ends and you multiply them together, and then you multiply it by 2. So essentially, you'll get in the very last portion, you have a 5x has to multiply by a 3, and we have to multiply it by 2. And if we do 5x times 3, that gives you 15x. And if we multiply it by 2, you'll get the 30x, which means that this is a perfect square trinomial. That is correct. So if we take the square root of the x squared and the square root of the 1, you'll get a 1x times a 1 times 2. Well, 2 times 1 times 1x will give you 2x, leaving you with that being a perfect square trinomial. The 3x and the 1 multiplied together times 2 will give you a 6, and therefore that it works. So the only one that will not will end up being the third choice, because this is going to be 2x times 2 times 2, which is 8, and in this case it is a negative 4. So we can actually cross out the third portion. Problem number 2. Determining dimensions. The length of the side of a rectangle window have the ratio 1.6 to 1. The area of the window is 2,822.4 inches squared. What are the window's dimensions? Circle the equation that represents this situation. Well, essentially, we know that if we were to multiply the 1.6 x times the x, or the 1x, right? We would then have to have that equal the 2,822.4 inches squared. So the only one that represents that looks to be the very first problem, that x times the 1.6x equals that. The equation solved below, write the justification from the box in each step. Well, in order for me to go from the original equation to the next one, it looks like I'm going to simplify the left side, so I'll cross this off. I'm then going to proceed by dividing by a 1.6, so I can get rid of that. I'm then going to simplify what I get, so I get the x squared equals the 1,764, and then I'm going to take the square root of each side. So if I were to take the square root of both sides, that's where you get the square will get canceled out, and the square root of 1764 is 42. So part 10. One side of the window measures, well, in this case, it will be 42 inches. The other side would have to measure 1.6 times 42, which is just about 67.2 inches. Great work. Solving a perfect square trinomial equation. So problem number 3. What is the solution of x squared minus 14x plus 49, which equals 25? So if I notice that the x squared and that 49 are both perfect squares, which they are, and I were to take the square root of both of them, I'll get an x and I'll get a 7. If I were to multiply those two together and multiply everything by 2, you'll end up getting that 14 is sure enough in the middle, and that works. So I'm going to factor this one out altogether. So instead of it being the x squared minus the 14x plus 49, I'm now going to change it to whatever the square root of 49 ends up being. In this case, it's going to be x with a 7, and then I'm going to bring down that negative, making it x minus 7, and we're going to make sure that all of that is going to be squared. Now the important part about that is the fact that if it's like this, we can now take the square root of both sides, especially noticing that 25 is in fact a perfect square. So I'm going to be left with a x minus 7, because that's not going to change. But notice there is no square anymore. It's because the square root eliminates it, and that's going to equal a plus or minus. Now when you're solving out a problem and you're trying to figure out what the answer actually ends up being, if you take the square root, you need to make sure that we talk about a positive as well as a negative. And that is solely because of, well, if something is a positive squared, it's going to stay positive. Meaning if I have 2 squared, it's going to be 4. But if I also have negative 2 squared, that will also equal 4. It gives you the exact same answer. So you have to show the positive as well as the negative. And therefore, plus or minus 5, or the square root of 25 becoming 5, ends up being the answer. But when you have a plus or minus portion, you have to solve it out twice. You have the x minus 7 is going to equal a positive 5, but you also have x minus 7 has to equal a negative 5. So the plus 5 and the negative 5 create 2 different equations, which will give you 2 different answers, which is perfect because we need to have 2 different answers. And in this case, I'm going to add 7 to both sides, so that it's going to be done the exact same way. And I'll get that x is going to equal a positive 12, and x will also equal a positive 2. So here's a key concept for completing the square. You can turn the expression x squared plus bx into a perfect square trinomial by adding b over 2 squared. Notice it's going to be b over 2. So we're going to take whatever's on the inside, divide it by 2, and then whatever that answer is, we're going to make sure we square it. Question 12. Circle the value that completes the square for x squared plus 16x. Well, if we wanted to complete the square, we would have to first take that b value, divide it by 2, which gives you 8, and then we're going to make sure that we have to square that 8. So 8 squared ends up being 64, and that is going to be the correct answer. So let's try using that in an actual question. Problem number 4, completing the square. What value completes the square for x squared plus 6x? Well, our b value is going to be 6, so it ends up being 6 divided by 2 squared. So when we end up doing all of that, we can then plug that in at the very end. So if we wanted to complete the square and write the expression as a perfect square, I'm going to do exactly that. I'm going to figure out that we have 6 divided by 2 squared is going to turn into the same thing as 3 squared, which equals 9. So if I wanted to complete the square, I'm going to add 9 to the x squared plus the 6x, or the original portion. and then I'm going to simply factor it out. So if I were to factor it out, you'll end up getting the x plus 3 squared. Now it's very important because notice 6 divided by 2 turned to 3. And notice we use a 3 inside the factored form. So essentially, you can basically figure out all the factored forms for the perfect square for what we're talking about right here to be x plus b over 2 squared. That is very, very helpful. So essentially, whatever you get before you square the original number is going to be something that we can plug into that formula. Now, if this was a minus 6x, it would become a minus inside the set of parentheses. But in this case, it's a plus, so we don't have to worry about it. Problem number 5. Solving by completing the square. Well, now that we know how to complete the square, how do we actually go about solving a legitimate question using that method? So what is the solution of 2x squared minus x plus 3 equals x plus 7? Use the justifications at the right to solve the equation. Well, let's take it step by step. We wrote the original. That's perfect. Let's rewrite the equation so that all of the terms with x are on one side. So I'm going to subtract that x to both sides. And I'm going to get a 2x squared plus a negative 2x. Now, you don't have to actually put a plus a negative 2. You can absolutely do just a minus 2x. Now, the reason that they're doing plus a negative 2 is just to show you exactly what that b value ends up being. So that cancels out, but then we also have to subtract 3 from both sides. And when you do that, the other side will cancel out, and we're going to be left with a positive 4 on the right-hand side. X squared plus something over something equals something over something. Well, in this case, for this part, we have a number for our a value, which means that we have to actually divide everything by whatever that a value is. Now, it is a nice one to divide out right now, but later on, it might not be. But no matter what, the only way you can complete the square is by making sure that the coefficient of the x squared, or the a value, is equal to 1. And in order for us to do that, we have to divide everything by 2. So you'll get an x squared plus a negative 2 over 2 times x, which is what we kind of showed up here, equals a 4 divided by 2. So we can simplify everything down. So we get x squared plus a negative 1x is going to have to equal a positive 2. And then we have to figure out, what does our b equal? Well, our b is given. It's negative 1. So I'm going to plug in that negative 1. So negative 1 over 2 squared is going to equal the same thing as negative 1 over 2 times a negative 1 over 2. So negative 1 times negative 1 creates a positive 1. But 2 times 2 on the bottom will give you that positive 4. So we have a 1/4. So we're going to have to add 1/4 to essentially both sides. So we're going to do the negative 1 originally, but we're going to add 1/4 to it. And that has to equal, in this case, it would be 2 plus 1/4, which is the same thing as, and I'm going to kind of do the little workaround, if you take the denominator of the number that we're adding, multiply it to the number on the outside, you'll get, in this case, an 8, and then add it to the top, you now know the fraction is going to be 9 over 4. So 4 times 2 gives you 8, plus 1 gives you that 9 over 4. It's a nice little quick way to do it. Okay. But then we have to figure out what goes inside the factored form. Well, like I said before, you just have to pay attention to whatever that b over 2 is. So in this case, our b over 2 happens to be negative 1/2. So that's exactly what I'm going to put. And notice what's inside the parentheses is going to be whatever we put inside the parentheses. I always say, if it's inside the parentheses, keep it inside the parentheses for this portion. Okay? And that is going to equal a 9 over 4. So nothing on the outside has truly changed. We have to take the square root of both sides, which basically on the left-hand side just eliminates the square root. But on the right-hand side turns it into a plus or minus, and then you take the square root of the top as well as the bottom. So when you take the square root of a fraction, you're going to take the square root of the denominator as well as the square root of the numerator. So we're going to have the square root of 4 on bottom in the denominator spot and the square root of 9 in the numerator, which means that we're going to have a plus or minus 3 over 4. So we're going to rewrite this as x plus a negative 1/2 because we're just bringing that straight down. And that's going to equal a plus or minus 3/2. The very last little bit is we're going to make sure that we add that 1/2 to both sides. So plus 1/2 plus 1/2. And it actually turns out to be a nice number. So we have a positive 3/2 plus 1/2. And we have a negative 3/2 plus 1/2. So our positive will become 4/2 because you can, since they're both the same denominator, we can just add across the top. All right, and 4/2 is the exact same thing as a positive 2. And again, the same denominator, so we have a negative 1 plus 1, which is the same thing as a negative 2 divided by 2, which equals a negative 1. So our x values will equal a negative 1 and a positive 2. In this case, they show it as a 1/2 plus or minus a 3/2. Which is perfectly fine, but the correct answer, and the answer that you should be putting, is the 2 and the negative 1. Problem number 6. Writing it in vertex form. What is y equals x squared plus 3x minus 6 in vertex form? Name the vertex and the y-intercept. Well, circle the equation that you can use to complete the square. Well, in order for me to base it off this complete the square method, I know that I have to add, at some point, a b/2 squared somewhere, right? So in this case, our b is going to be 3, so we're going to have to be adding a 3/2 that is being squared somewhere in this problem. Now, it looks like we're adding a 3/2 right here, but it's not being squared, so we can eliminate that choice. We are not adding a 3/2 squared in this portion, or the last one. So the only one it looks like that we're actually legitimately adding a 3/2 squared to happens to be the first one. But it's kind of weird because you see a minus 6, which we see the minus 6 part. That's fine. But we also are subtracting a 3/2 squared. And that is there for a reason, because that is correct. And that is because normally when you're solving it out, if you have something like an x squared plus 3x equals a negative 6, you're solving it out, you're going to make sure that if you add it to one side, to make sure everything stays nice and even and balanced, you're going to have to add it to the other side. Well, in this problem, we can't do that because we're not solving it out. We're just trying to write in vertex form. So in order for us to make sure everything stays the same, although yes, we are adding that number to it, it makes it slightly off balance, we're going to actually subtract the exact same amount away. So essentially, we're adding 0 because 3/2 squared minus 3/2 squared is exactly that. I mean, it's 0. But the reason we're doing that is solely so that we can rewrite this and simplify it down. 18. Simplify the equation. The first thing I'm going to do is I'm going to make sure I change this to a negative sign because it's supposed to be subtracting by that 3/2 squared. So we have y is going to equal an x plus a whatever's inside the parentheses. We're going to keep inside the parentheses, so it becomes x plus 3/2 squared minus a 6 minus, in this case, it's going to be the 3/2 squared, and 3/2 squared is the same thing as 3 squared, which is 9, divided by 2 squared, which happens to be 4. So we're going to put a 9/4 in this box. All right. Let's simplify it a little bit farther down. So we're going to get the x plus 3/2 because we're going to keep it kind of the same. But this is going to be plus. In this case, we have to make sure that we simplify everything down 100%. So let's write off the negative 6 minus 9/4 off to the side. And let's see if we can simplify this down. Well, looking at this, we have a negative 6, we have a negative 9. So as long as we had the common denominators, we would be able to add straight across. So I'm going to use that little method. So I'm going to take that 4, I'm going to multiply it by the 6. I'm going to get, in this case, a negative 24. And then I'm going to subtract 9 from it. And when you subtract 9 from a negative 24, you're going to get a negative 33/4. And I'm going to write that in right there. So our vertex is going to be currently at the point of the opposite of whatever's on the inside. So it becomes a negative 3/2 with the outside, which is a negative 33/4. And the last little bit, the y-intercept, will actually come from the standard form that is given because it already tells us what the y-intercept is in our C value. So our y-intercept is going to be a -6. Great work. And we finally made it the lesson check. How can you rewrite the equation x squared plus 12x plus 5 equals 3 so that the left side of the equation is in the form x plus a squared? In other words, we completed the square on the left-hand side. Well, if that was the case, I'm going to subtract the 5 to both sides because I just want the variable, or the x squared and the x, on the left-hand side. I don't want the numbers there. So we're going to get x squared plus 12x equals a -2. I'm then going to take that b value, which is 12, I'm going to divide it by 2, so we get 12 over 2 squared, and that's going to equal our -2 because we're just bringing that down. Well, since you added 12 over 2 squared to the left-hand side, we must add 12 over 2 squared to the right-hand side, and that will give you an x squared plus 12x plus, well, 12 divided by 2 equals 6. If we were to square it, it would give you 36. In this case, it would be, again, bring down the -2 plus a 36, because whatever you do to one side, you must do to the other. Simplify it down even farther, we'll get the x squared plus 12x plus 36 has to equal a 34, because that's -2 plus 36. And the very last little bit is complete the square. Again, if it was inside the parentheses up here, it's going to be inside the parentheses down here. So originally it would be 12 over 2, but 12 divided by 2 is 6, so I'm going to put a 6 down here, and then that is going to equal your 34. And that is in the form x plus a times squared equals the c. And that is it, everybody. I hope everyone has a wonderful day. Stay out of trouble. Don't do anything stupid. And I'll see you guys in the next one.